let's take a look at number 3 here. So we have the maximum load of a horizontal beam that is supported at both ends varies jointly as the width and the square of the height, and inversely as the length between the supports. A beam 6 meters long, 0.1 meters wide, 0.06 meters high, supports a load of 360 kilograms. What is the maximum load supported by a beam 16 meters long, 0.2 meters wide, and 0.08 meters high? So here I have 4 variables, right? And if we hear them, we've got load, we've got width, we've got height, and we've got length. And some other buzzwords that are floating around here is I see varies jointly. So this is going to be one of those variation problems, right? We're going to model with variation. So I vary jointly with the width and the square of the height, and then inversely as the length. So I have 4 letters. I'm going to use maximum load. I'm going to write that with a capital L. I'm going to write width with a W, H with a height, and then length with a lowercase l. And you can see I have a complete set of information, right? I have a length, a width, a height, and a load. And I'm going to use those 4 numbers together to solve for my constant of variation once I write my equation. And then once I have my K value, my constant of variation, I'll plug in 16.2, 0.08 and find capital L. So let's write our equation. So it says the maximum load, right, varies jointly. So I'm going to put a constant of variation, and it says as the width and the square of the height, right? But it says inversely as the length. So that means I'm going to divide by lowercase l. And then I'm going to take this complete set of information. So let me go ahead and do this, right? It says when you have a load of 300, or if you've got a beam 6 meters long, 0.1 meters wide, 0.06 meters high, it's got a load of 360. So I'm going to plug those 4 numbers in. The only thing I don't have is K, which I'll solve for. So our width was 0.1. Our height was 0.06. I got to square that. And then our length was 6. So if I want to solve for K, what I'm going to do is I'm going to multiply the 6 to this side, right? If I multiply both sides by 6, I'll knock out the fraction. Right, so I'll multiply that 6 over, and then I'm going to divide by 0.1 and divide by 0.06 squared. So I'm going to just do that on my calculator all in one fell swoop. So let me head over here, and I think we can see this. So I'm going to take, can we see the 360? Let me just scooch this a bit. So I'm going to take 360, I'm going to multiply it by 6, right? So if this is over here and I want to solve for K, then I'm going to divide that number by 0.1. And then I'm going to divide again by, and I'll put it in parentheses, 0.06 squared. And I get K being a huge number. Let's see, that's 1, 2, 3, 4, 5, 6, 6 zeros. So that is K is going to be 6 million, which is fine. Whatever K is, K is. All right, so let me go ahead and rewrite this equation. So L is going to equal 6 million, 1, 2, 3, 4, 5, 6 zeros. Okay, WH squared over L. So we now want the maximum load. We're going to solve for capital L. I'm going to plug in 0.2 for the width and 0.08 for the height, and then 16 for the length. So let's see what we've got here. My load in this case is going to be 6 million. So 1, 2, 3, 4, 5, 6 zeros. All right, width was, what was it? Here it is, 0.2. Height was 0.08. I gotta remember to square that number. And then let me divide that by the length of 16. All right, so let's just see what this number is, because that is ultimately my answer. I might sneeze in a moment, so I apologize. Yep, it's gonna happen. Wait for it. Excuse me. Okay. We've got 6 million. I'm going to multiply that by 0.2, and then I'm going to multiply that by 0.08 squared, right? And then I'm going to divide that number by 16. So when I solve for that, I get 480. So my load was 480. Let's see what the units on this are. Let me move this over here. Looks like load is in kilograms. And that looks to be option B. All right. Thanks so much, everyone. Bye.